Hey guys, what's up? Today we're looking at doing an example of applications for antiderivatives. So this example says a car braked with a constant deceleration of 16 feet per second, producing skid marks measuring 200 feet before coming to a stop. How fast was the car traveling when the brakes were first applied? All right, so I've got a little diagram here. We've got the DeLorean and it's gonna start braking right here at this point. So we'll call this point right here, we'll say that's when t is equal to 0. So right here, t is 0. And we'll also call this point s equals 0, because we're really just concerned with the displacement past this point right here where the brakes are applied. So we'll call this down here, this is s equals 200. All right, so that's our setup, at least for our diagram. Now, what do we do to try to solve this problem? So we're given an acceleration, and the acceleration is 16 feet per second in the other direction. So the acceleration is actually in this direction, and it's negative, we'll call it negative 16 feet per second. So from here, we know that if we want to get the velocity, we can just integrate the acceleration. So velocity would just be the antiderivative of the acceleration, so negative 16 dt. And if we integrate that, we get negative 16t plus a constant, we'll call it c1. Now, that's our velocity. It's negative 16t c1. So if we plug in v of 0, well, that would be 0 plus c1. So c1 is actually the initial velocity, and that's what we actually want to find. So c1 is just v0, the initial velocity, and this is the thing we want to find. So find this quantity right here. So find this. All right, so that's where we're going. Now, s of t is the antiderivative of v of t. So s of t is integral v of t dt, which is going to be, if I antidifferentiate these two terms, I get negative 8t squared plus v0t plus c2. Right, and now s of 0 is just 0. That's where we start pressing the brakes, so that we called that point 0. So s of 0 equals 0, and that's going to be c2 when I plug in t equals 0. So c2 is actually 0. S of t then is really just negative 8t squared plus v0t. Okay, so now we've got our velocity, v of t, and our position, s of t. So velocity, just remind ourselves, is negative 16t plus v0. Now, how can we figure out how far or how much time it took to make the skid marks of 200 feet? Right, so when the velocity is 0, s is equal to 200. So when we come to a stop, velocity is 0. So if v equals 0, then that would say that negative 16t plus v0 equals 0. So that would tell me that the time it takes to stop is 16, or v0 over 16. So time to stop, we'll call it TS, is v0 over 16. Now, we know the position after this many seconds. How can I get v0? Well, I take this time to stop and plug it into s and set that equal to 200. S of TS should be equal to 200. So that's going to tell me that 200 should be equal to negative 8 times v0 over 16 quantity squared plus v0 times v0 over 16. All right, after we simplify that a little bit, we'll get negative 8 v0 squared over 256 plus v0 squared over 16. We can combine that into a single fraction. We'll get v0 squared over 32. So that will tell us that v0 squared will be equal to 6400. And that tells us that v0 is 80. Now, 80 what? Well, our units all started out in the same thing, feet and seconds. So this is actually v0 in feet per second. If you convert that to miles per hour, that will be about 55 miles per hour. And that is our solution to this problem. I guess it just depends on what the actual problem asks for. If it wants it in miles per hour, you convert it. If it wants just feet per second, you leave it 80 feet per second. But that's how we do it.